So for our first on the agenda, we've got a fireside chat with Justin. He's one of the founders of Sparsity. Justin, you want to take a seat? All right. Justin, how's it going?
Great. How are you?
Good. Good. Thanks for being here.
Very glad to be here. Thanks everyone for being here.
So Justin, just to give everybody a little bit of background about yourself, could you kind of tell us professional background, how'd you get here?
Yeah, totally. So I'm Justin. I've spent my pretty much whole career working on algorithm and making software run faster. I did parallel computing research at MIT and worked in a bunch of Web 2 company building systems like Microsoft, Google, NVIDIA, Snapchat. I spent probably 6 years in AI, including 1 year in brain science at MIT. More recently, I've been doing blockchain security, basically analyzing on-chain data to detect attacks. And right before starting Sparsity, I was a zero-knowledge person. My car plate is actually ZK Snark. And we had a lot of fun building fully on-chain games using zero-knowledge proof and multi-party computation. And I'm also a lecturer in zero-knowledge proof and blockchain development in NTU in Singapore.
Awesome. Thank you. So a combination of Web 2 and Web 3 experience, lots of development experience. It's great. And also very nerdy license plate, by the way, but cool. Okay, one of the founders of Sparsity. What is Sparsity?
Sparsity is an execution layer that removes the speed limit on blockchains. Like 2 years ago, we was very intensively developing the DApps, like using EVM, and we just realized there's such a big gap between the developer experience and performance between Web 2 development and Web 3 development. So it's even like a baffling. You probably, people develop dApps, you wrestle with the 24 kilobyte limitation on EVM, the latency, the gas cost, and the throughput. It was just strange, like this thing, why is this so difficult to use? And we dive in, and I think we find out a root problem and develop a good solution for that, which is Sparsity.
Awesome. And just to learn a little bit about y'all in the audience, I mean, backgrounds, are you mostly developers? Like, raise your hand if you're a developer. Okay, good set of hands. And then what's the rest? Like Web3 enthusiasts, business people? A couple, okay. And there's the rest are just what, meme coin degens? Is that, what's up? Okay, hey, rock on. I appreciate the one hand up, thank you. All right, well, we're happy you're all here. Admittedly, this will be, I think, more on the technical development side, but we appreciate, I think, everyone's involvement and hope you learned something today. Justin, could you talk a little bit about your personal journey and why you decided to launch Sparsity?
Yeah, totally. Like I said, I personally feel the pain of Web3 development. In Web 2, it was very sophisticated, I would say. Let me just take Snapchat, for example. So I spent 4 years there. The system was handling 6 to 7,000 transactions per second. And not just financial transactions. They are complicated transactions with cache lookup, with database handling, with the data blob handling, with this. They are mutually dependent through this social graph, and they're also depending on dozens of background cron jobs, and at the same time there are hundreds of engineers pushing code on a per minute basis. It's a really complicated machinery to build this. Not even the most complicated software. Like Snapchat, it's not compared to Google, Microsoft. I mean, I also work at Google, so Microsoft. It's way more complicated. So you can see the gap between the Web 3 development experience. It's I also calculate there are probably 100 million times difference between the Web 3 throughput now and the Web 2 throughput. So I mean, we all talk about DeFi is pretty much the dominant application in Web 3 now. We want real consumer applications like social, search, gaming, but just look at the infrastructure and the developer experience. It's not even close. So I can talk more about that. I think I'll be very short and talk later. So I think, but once you dive down into this Web 2 machinery, you see that those complicated software is actually built from really cleanly separated, designed, and modular composable primitives, like database cells, cache slot, threads, or data reduction. So those things are very loosely coupled primitives that you can use to build really big software. And there are many ways to call that. Someone call like loose coupling, modularization, composability, and sparsity is another way to call it. So we are building the Web3 infrastructure the same way, make blockchain more modular. You know, like today, a lot of things in blockchain are very monolithic. And we can dive into that later more, yeah.
Well, so sparsity is a deep technical term, and obviously chose to name the company that to sort of reflect that. I think DeepSeek, another, obviously has made a lot of waves in the last couple months, sort of their AI implementation. I mean, I think they're doing something with sparsity conceptually as well, right?
Yeah, that's a great question. So if you search online for like DeepSeek and sparsity or AI sparsity, you will find a lot of articles. So they are using a different type of sparsity, which we just have the same name. But underneath, they are rooting on the exactly same thing, which is I would call modularization or loose coupling. So let me spend a couple minutes explaining how DeepSeek works. So DeepSeek is this huge AI model that internally is modularized into many, many small AI models. And every time a request token comes, it will only activate a small fraction of the AI model. To be specific, about 5% of the AI models within DeepSeek. And that is why DeepSeek is like about 20 times faster than like the open AI models or other open source model with similar number of weights. And it's also 20 times cheaper. So they call this kind of a model mixture of expert model, which is sparse. And I like to use the human body analogy. Like, for example, all your fingers can move separately. They are not like stick together, and like that will be brittle and slow. So that's one type of modularization. And our brain also have like a visual cortex, language center. It's also compartmentized. So our body is designed in a way that is very modular and allow us to function efficiently. So in software, we also do the same thing. We call it separation of concerns. You build different module for different things. So sparsity is basically built on that with that principle in mind, that we want to like modularize, basically be the dedicated computing layer, while let the blockchain be the money management layer.
Got it. And I saw a show of hands earlier. At least some of you are not developers. I am not a software developer myself, so my background is in economics. Very similar concept in like specialization, right? So as a society, as an economy, we gain when folks specialize in one thing, maximize their profits that way. I mean, it's effectively the same, a business analog to sort of the technical sparsity that you're talking about here, right?
Yeah, totally. So sparsity network underneath also like has this loose coupling and the modularization, which allows the sparsity network to run computation massively parallel. Like you can use Web2 design patterns like MapReduce very easily on sparsity and integrate seamlessly with Web3. Yeah, so deep down, this sparsity with the DeepSeek sparsity are both based on modularization.
So conceptually similar.
Yeah.
Great. I think you've touched on it a little bit when explaining sort of what sparsity does, but can you just like really high level summarize what are the problems that you were really trying to solve for? It sounds like based on sort of the gaps you saw from your Web 2 experience coming to Web 3.
Yeah, totally. I think one of the biggest dilemma for Web3 today is that we are solving two conflicting problems at once. One of them is managing money, which was what the blockchain was originally invented to solve. Like after the 2008 subprime crisis, people like Bitcoin was invented as the better platform to manage money, like more transparent, more secure, and more democratic. And the other problem we're trying to solve now is compute. Later Bitcoin was upgraded to, upgraded to add EVM to be Ethereum and called the world computer. But today, I think if you try to build anything on crypto, on blockchain, you will find that nothing works except the DeFi, right? So I think fundamentally the problem is because money management and compute are conflicting requirements. When you have a lot of money, you want to be secure and transparent. And actually, you want to be slow, right? You don't want to be too fast when you have a lot of money at hand. And when you have compute, you want to go really fast, parallelized, low latency, developer experience, developer freedom. I believe these two a requirement is very hard to solve in one solution. I like to use two analogies. One is the CPU and the GPU. So I see the existing blockchains as the CPU. It can get really fast, but it will saturate off at a certain point. And then we need some more specialized machinery to come in to handle the more intense workload, more parallelized, massively parallelized, to bridge the gap with Web 2, or even you say unify with Web 2. So the other analogy I like to use a lot is the heart and brain dichotomy. You know, to build one system that can handle money management well and also compute well, I think it's almost like put the brain and the heart into the same organ. By imagination, you can imagine it's like really complicated. It will be very complicated, like the design, which is why evolution didn't choose that path, because it will make the host very vulnerable. Instead, the evolution chose this modular design. Right? We have brain to handle the compute. One second, and the heart handle the really most important substance in the body. So that's basically what the design principle behind Sparsity. Sparsity is meant to be the GPU for the blockchain and to be the brain for the blockchain, while the blockchain will handle the asset, what's the most important asset in the ecosystem. Can I have?
So is Sparsity intended to replace smart contracting layers like Solidity or MoveVM, or is it working alongside?
Alongside for the Sparsity itself is not a blockchain. We are an execution layer that works seamlessly with other blockchains.
But MoveVM isn't a blockchain. It's a decentralized application. So
You mean?
does it replace that?
Let me answer. Let me give you one specific example. So any smart contract from any blockchain, they can delegate the workload to Sparsity. Then we will execute that, and then settle back with a proof.
Build the smart contract and delegate that computer task to that modularized component to Sparsity.
Yeah, exactly. And in Sparsity, you can massively parallel. So the smart contract itself and the workload on Sparsity, they form this continuum of your business logic.
Is Sparsity running on decentralized infrastructure?
Yes. Yeah, it's running on decentralized. It is running on. Thank you for the question. It is running on decentralized infrastructure, and so it's running from machines contributed by the community. People stake coin to join the community, to join the Sparsity fleet, and you can. We're getting into a little more detail now. So the specific computing unit on Sparsity are like a small blockchains, and as a developer, you can dictate how strong, how big the blockchain is. For example, you can say, this function in my software needs to be run by 100 nodes to reach consensus. And the other function in my software is less important, so it only needs to be run by 5 nodes to reach consensus. So you can customize the strength of consensus in your software, which is another thing I think when you build big software, you will need that. You don't want the blockchain to make all this trade-off for you, because if you build on OP, you have to stick with 7-day window, right? Even I say 1 day is enough for me. Yeah, well, definitely love to dive into details there.
What do they use for looking at consensus? Because complicated computation is very difficult to describe the tools you're doing the right thing. That's the main challenge in the decentralized environment.
So in case anybody can't hear, the question was, how do they build consensus? Sorry.
So there are multiple ways. So first of all, the question, the fundamental question is this kind of off-chain computing. How can we prove that and settle back to the original blockchain? Right? So that there are multiple ways. You can do threshold signature. You can do the TEE or ZK. So depending on if you are doing TEE and ZK, then you kind of don't need a consensus off-chain to some extent. But if you are using threshold signature, we will provide this Docker-based tendermint solution for you to drive consensus. So as a developer, you just need to provide your business logic through Docker, and make sure the Docker is deterministic.
That's not the question.
Yeah.
The question is, in a very complicated computation, also in parallel environment, the result of 2 machines running may not even be the same.
Yeah.
Another way to phrase the same question is you're trying to replace the problems or solve the problems of advanced decentralized systems with another decentralized system. How does your system avoid the problems that the other decentralized systems are running?
Yeah. So the difference is because in our system we have a few key technologies that's different. One is we have this small, we call it ephemeral rollup, small blockchains. I see this small blockchain as a decentralized CPU. It's basically like a CPU, but it's decentralized. And the other key thing is like once like a multiple CPUs communicate, how can we settle their like overall result to the blockchain? So that is through proofs. Like for example, this CPU calls that CPU and then fan out to another CPU, then reduce. So you can construct this whole thing into like a DAG-shaped proof. And so you can basically settle this whole thing onto the blockchain as like a hash graph proof. And we actually have like a demo that's on Twitter I can show you. Basically, as an analogy, I think like this like a micro blockchain is the Web3 version of the Web2 CPU, and the proof is almost like a Web3 version of the Web2 networking. So once you have these two primitives, like a single CPU with customized consensus strengths, and a way to let them communicate and still generate proof of their overall computing result, you can pretty much compose anything and then still settle back to the blockchain. Basically, not like a composing software using the same methodology without compromising the Web3 trust.
Okay, I at least saw sub nodding as the answer, but given how technical that was, maybe we can talk to you offline
Yeah,
a little
we'll
bit.
definitely love to dive in later, yeah.
I mean, that was great. If you guys have questions, try to save them for the end. I think we'll have a few minutes for just open Q&A. But I appreciate the audience involvement. This is great. They're good questions, so thank you. I just really fast, why don't you talk a little bit about like where's Sparsity at in its journey? And then we can talk a little bit more about sort of AI, since that's sort of the broad theme for today.
Yeah, totally. I would love to.
So Sparsity journey, how's it going?
Yeah, it's going great. So we graduated from A16Z incubator last fall, and it was a great experience. We iterate our tech and the vision with super talented people from A16Z on a weekly basis. And I also post a lot of posts on my Twitter with my notes of the journey. Please follow me on my Twitter account as well. And recently,
what is your Twitter? Just so that
just at Justin Zhang.
Thank you.
And we just launched our DevNet 1.0 last week to start our building public. And today we are hosting a hackathon where you can build AI agent using the AG2 framework, which we will talk next on Sparsity. This also showcases the power of this design, that because we are using Docker container developer experience, the developer interface, it's very easy to migrate your Web2 workload into Web3. It's kind of seamless migration. And we also have a bunch of demos. Some of will be shown in the other room. We are spending a lot of time on AI now. We have grow our AI team. I mentioned like DeepSeek is also built on a concept of sparsity, and we are spending a lot of time thinking about that, seeing how that can synergize and resonate with the sparsity network. Of course, we are also hosting today's event because of our belief in the future of AI and AI agent.
Awesome. I mean, so great progress. But I have to ask, because like when I've looked at some of your stuff in the past, very gaming focused. Are you moving away from gaming? Is this a pivot? How are you thinking about sparsity versus gaming?
Thanks for the question. So we love gaming. We started Sparsity on gaming. And I have been playing games and developed games since I was a kid. I think my most memorable game development experience was to write the first-person viewpoint game and then rewrite the hotspot in pure assembly to do real-time rendering without the help of graphics card. I mean, for people who have done that, that is quite a spiritual experience. And I mean, long story short, we enter Sparsity from the gaming point of view. And I do think gaming is a great way to stress test system. A lot of other companies also start from gaming, like OpenAI, DeepMind, NVIDIA, and they later generate that solution to other problems. So as we spend a lot of time on gaming, we also talk to other customers. We realize that there's a tremendous demand from other verticals like AI, DeFi, data processing, and like social for solutions like Sparsity. They are demanding our solution. That is why we're spending more time on the other verticals. So it's not a pivoting, but more like broadening of scopes.
Sure. Well, once you built the technology, it's application generic, right? So
yeah. So underneath, they are all like a computing problem. AI, like gaming, they are all computing. Like like we said, if the primitives was designed good enough, you have like a flexibility to compose very complex software. So underneath, they are all computing, and the fundamental problem we're addressing here is how to, marry computing with the trust on Web3.
Got it. Thank you. And I'll just say, when I beat a game, I typically just went to the next game. I didn't try to recode it in assembly, but that's great, Justin. That's great. Okay. A lot about Sparsity. I hope that was a little bit educational, just to explain where you're coming from and sort of the products and solutions you're building. Nature of today is about AI, agent Singularity. Tell me a little bit about your thoughts on sort of AI and crypto and how those things come together.
Totally, yeah, happy to offer my view. I think that AI and crypto are orthogonal technologies. AI, in my view, is to make machines smarter, and crypto or blockchain is to make machine responsible, like to make sure that smart machine do not cheat, do not commit crime. I think there are two types of AI plus crypto projects. One is to apply AI to crypto, basically using AI to help you write smart contract, use AI to help you audit smart contract, use AI to help you trading. So that is very straightforward, and the heavy lifting is on the AI side, how to train better AI model, how to build better AI agent. I know a lot of projects have done work in that space. I think it's really exciting with traction. The other side is applying crypto to AI, which is how can we make, for example, AI inference decentralized? How can we make AI training trustless? So I think that's more interesting from a crypto technology point of view, and the heavy lifting is on the crypto side. There's a lot of projects working on that space as well. Sparsity is definitely one of them. Sparsity making it really easy to make AI inference and the training trustless, decentralized. So that's the how, but I think the more important question is the why, like why AI needs to be on-chain. And I can dive into that as well.
Yeah, no, I think it'd be good to explain why someone would care about that, which is good. And obviously, we're going to have a bunch of other speakers, as Justin sort of alluded to today, sort of working at that crypto AI intersection. But yeah, why would I care?
Yeah, totally. I think, in my view, only things that need extreme trust need to be on-chain. Like blockchain is this commitment device that the value it brings is really a kind of transparency and trust. So now the question is, what kind of AI apps needs this kind of trust? Like when I generate image using Midjourney give me 20 images for me to choose. I don't really worry if someone is tampering with the algorithms behind, try to manipulate result in some way. But some other AI models, if the AI models do authentication, like the word coin case, or the AI is trying to do design authorization. For example, in security, we have a lot of AI models deciding whether this incoming transaction is malicious or not, and then they're deciding whether to let that transaction go. So for that AI models, I do think there is basic AI models are making consequential decisions. People have a concrete reason to hack those AI models, and therefore I think there is concrete reasons for the AI model to be on-chain. But I think for most of the generative AI applications, I don't think the reason for the AI model to be on-chain is that clear at this point. But like we talk about like AI singularity, I think that's basically, I mean, the singularity basically means it's like it's a very important future, but something we cannot see very clearly. I think like if AI is just to generate meme images, it's not gonna be that consequential. But at some point, AI is gonna help us manage money, like policing the street, do all these like really, really important things. That at that time, I think those AI will have very concrete reason to be, have this kind of decentralized trust, to not fall into the hands of a few people who can manipulate them.
Yeah, so if you think about the first wave of AI being, LLMs that individuals interact with, Web 2 black boxes, it sort of doesn't matter to some extent if you're just trying to get advice on something. I mean, please fact check LLMs. I don't know if any of you guys have gotten bad answers from ChatGPT. I do almost every day. Watch out for that. But still, amazing technology, lots of capabilities, right? When it's purely educational, risk is relatively low. I mean, I think over ETH Denver, I've heard at least 24 pitches about letting agents actually make trades on your behalf, and how to try to add guardrails to that. Obviously, once it starts risking your own money, it's obviously you care more about how the agents work. Having that code be transparent is important. Going to self-driving cars, if that actually does become a thing, the risks go up and up. So there's certainly a value going forward to having this open AI access, being able to see the model on a blockchain, understanding it, make sure it's transparent. So it's great. And I assume everybody who signed up for this is somewhat nerdy and so knows conceptually what singularities are, like that tech kind of sci-fi concept. I see a couple nods. Just, do you want to say anything else about agent singularity? Maybe we'll do a little bit of Q&A.
Sure. First of all, I think those hacks already happen. People already hacked the Tesla AI and hack a bunch of AI. Sometimes not to. I mean, there are many type of hacks. Some they just manipulate AI model by enter some specific input, and sometimes they make the AI say unethical things. All of that. I think for AI engine singularity, one thing is very clear now, which is there's no turning back. We are on this, it's going, and where we are going, I think a lot of it's hard to predict. From both regulation, technical, tax aspect, and also AI safety. But I think it's very clear that we are going towards this mysterious unknown feature that I think nobody of us has ever experienced before. I mean, I know in AI, there's people talk about AGI a lot. My personal view is the major bottleneck for the AGI is how to bridge the language reasoning with actual reasoning. Maybe I don't. I mean, I think the AI world is kind of have this dichotomy of we have this language model which is a C3PO that can talk but doesn't think very deeply, but also have this a chess playing program or an alpha star that can think really deeply but cannot talk. I believe once we once we can bridge the dichotomy between them, it will be the time we are really kind of get close to AGI. And I personally believe that agent is one way to bridge that in the near future. Basically, we use agent, you can kind of combine the thought, language-based, the general purpose thought process with a structured reasoning framework, so that it has both. You can bring both ends to the same model. But in the long term, we will have an end-to-end solution to that.
Awesome. Thank you, Justin. We're already a little late, which is so typical of something like this. But if there's a couple questions, I think we can answer them. I think I saw at least one hand up a second ago. No?
Yeah, I just want to ask about the concept of AI projects. And you mentioned a couple of different ways of looking at it. And when you look at what Virtuals, for instance, is trying to do with an ecosystem of AI agent projects that are interacting within the ecosystem, and seem to be more conceptualizing the AI as kind of leading the way for the progress of the entire documentation and stuff.
You mean basically you want me to comment on the Virtuals project, how the AI agent is leading?
Yeah, I just want to conceptualizing what is an AI project is an interesting question. So figure out, I have a project, what's your agent doing, right? And I have my ideas about it. You have none about the project, but there's a lot of different projects that are doing a lot of different things that seem to be beyond what you described. And when you look at what they're doing Virtuals in terms of an ecosystem of different projects that are all intended to kind of work together.
Yeah, I think if I understand a question correctly, you might be asking about the interaction and composability between AI agent. Yeah, I think that's definitely AI agent is it's a form of intelligence, and the intelligence is partially social as well. So for sure, I think Tri is an expert here. She knows, can tell you why the multi-agent system is more powerful than a single-agent system. So I completely agree. The interaction between agents is a essential component for the agentic computing. Yes.
Well, and maybe something you alluded to in the theme of today of singularity, right? If AI is actually able to learn from each other, wow, okay, you can run extremely high numbers of those instances and have it rapidly improve more than, one person, for instance, learning.
We're all making business deals
an interesting future, right? Awesome. Any other questions? Otherwise, once, twice, awesome. All right, thank you, everybody. Thank you, Justin, for coming up.
Thank you. Thank you, everyone.